Here we go with integration by parts from our supplemental textbook, Chapter 3, Problem 53. I've taken the integrand, which is natural log of x, the whole thing squared over x, and I've kind of yanked the 1 over x off to the side as a reminder that when we try to assign parts for integration by parts, the choices aren't natural log of x squared and x, they're natural log of x squared and 1 over x. The next steps are hidden by the Fantastic Four and Mole Man here. So remember, for integration by parts, we need to assign a part to be f of x and a part to be g prime. And then we'll build a new integral that replaces f with f prime and g prime with g. There's one good choice. Well, maybe it's not a good choice. There's one choice, and one possible choice that isn't really a choice. Because if we put this term here, we would have to know what the antiderivative of the natural log of x squared is, which we don't. And so that's a non-starter. So really, our only choice is to make the assignments this way. One part becomes f of x, the other part becomes g prime. And then we compute from those two, they're kind of partners. So for f prime from f, that's a little bit of a chain rule. 2 natural log to the first times the derivative of natural log. And then from g prime to g, well, look at that. We're about to introduce another natural log. Did that really get us anywhere? Well, we're going to find out. Now, I'm going to go ahead and just assert for this problem that x is positive so that we don't have to mess with absolute value signs here. Here is the integration by parts formula that we're now going to load up with all of this good information that we just developed, and now Mole Man can go away. So here's the original, which is this. We're going to reassemble it and trade the original integral for something that's hopefully a little bit better. So we're going to do f times g. So this term here is f times g. So the original, I'm not going to write it again, is f times g. Well, that's a natural log cubed, right? This times this, natural log cubed, and then minus the integral of f prime g. And when I multiply this by this, I'm going to have 2. I'm going to have natural log of x, 2 of them, squared, and then my 1 over x, I can just kind of mush it back all together with the dx. And, oh my goodness, up here is the integral of natural log of x squared over x dx, and that's equal to the natural log of x cubed minus 2 times the integral of, my hand will be out of the way in a second. See, we'll get there. We've developed this statement, which means, A, we've tangled ourselves up in a knot, because now we have the same integral showing up in different places. But it's a good knot to be in, because we now have the ability to solve this integral without actually having solved the integral. Because if I add this term over to this side, now I've got 3 of these integrals altogether. Like so. Now, this thing being equal to all of this isn't, I've got one item and it's equal to this term plus -2 of this item. Remember that this critter, this indefinite integral, is actually representing an entire class of functions that are all distinguished by this plus c. So I'm not really saying that this one thing equals this thing minus 2 of those things. I'm saying that this thing on the left can have a whole bunch of arbitrary constants with it, and so can this. And so we're still going to go ahead and recognize that this may differ from this by an arbitrary constant, just like we do with definite integrals or indefinite integrals anyway. But what that does is it allows us, I'm dividing both sides by 3, and arbitrary constant c divided by 3 is still an arbitrary constant, so let's just leave it like that. And there we go. That is the result for this integral. Now, if you roll this back to the start and you look at the answer, you go, wait a minute, wouldn't this have been easier if we just started off with u equals natural log of x, and then du is 1 over x dx, and then we're integrating u squared du, well, yeah, that would have been easier, but it wouldn't have been an example of integration by parts.